So this is 2012, number 22. And if we look, they want absolute maximums. So the first thing in our head, where do absolute maximums occur? You should say critical points or endpoints, right? Now the next thing is to consider, you need to know what ln of x looks like. Everyone should know ln of x looks like kind of like this. So the domain of ln of x is between 0 and infinity. Therefore, there are no endpoints. There are no endpoints. So let's figure out what's happening. This, I need to find the critical points because that's the possible location of a max or min. So taking the derivative of that function, we have to do low d high. So low d high is 1 over x minus high d low, which is 1 over low squared. And here, those will cancel. And so we have a beautiful derivative of 1 minus ln of x over x squared. What are critical points? First, where does the derivative equal 0? It equals 0 when the top equals 0. I add ln of x to both sides. Now to get rid of ln of x, I e both sides. That will cancel, so x equals e. There's one critical point. Now, where does the derivative not exist? It doesn't exist if I divide by 0. So when the denominator equals 0. Do I have two critical points? And the answer is no, because remember, what is the domain of my function? 0 is not part of the domain. If that's not part of the domain, it can't be a critical point because it's not even part of the graph. So at this point, I only have one critical point. And this is where it's important to know that second theorem about max and mins. If you have a continuous function that has only one extrema, that extrema is an absolute extrema. So we need to find out, is this, we're looking for absolute max. If that's a relative max, then it's an absolute max. If that's not a relative max, the answer would be E, does not have an absolute maximum value. So we need to figure out, is there a relative max at E? Well, my left border is 0 and my right's infinity because that's my domain. So pick a number between those. I like 1 and I like e squared. Why e squared? You will see why. And here we want the derivative. And the whole purpose of this is to find out if that's a relative max or min. And we know that happens when the derivative changes from positive to negative or negative to positive. That's what we're looking for. So what is the derivative on each side of E? Well, let's do this. Plug in 1. What's ln of 1? What's ln of 1? 0. So, 0. So 1 minus 0 is 1. And 1 squared is 1. That's a positive number. So the derivative at 1 is positive. Let's plug in e squared. Ln of e squared, those cancel. Ln and e are inverse functions. 1 minus 2 is negative. And the bottom, e squared squared, is e to the 4th. A negative divided by a positive is negative. Here's my conclusion. Since this is multiple choice, I don't have to write this reasoning out. But the derivative changes from positive to negative e. Therefore, there's a relative maximum at e. But since this is a continuous function with one relative extrema, that's an absolute extrema. So the absolute extreme occurs at e. But be careful, read the question. It's asking what is the absolute maximum. It doesn't say at what x coordinate does it occur. It's actually asking what is the absolute maximum. It's asking for the y value at e, because the y value is what they're talking about, the maximum y value. So if you plug in e here and e here, ln of e is 1 and e is e, so the answer is 1 over e. Bam. So that is the maximum value.